Okay, if you're working in aerospace or maybe power generation, you definitely know the pain points with simulation tools. They're super specialized, they're proprietary, often incredibly expensive, and they just don't talk to each other. So today we're diving into SimTurbo. It's a software platform from Controls Research LLC, developed by Paul Hoffman, an industry vet. And the claim is it unifies gas turbine engine simulation and, crucially, the controls design process. So our mission here is pretty simple. Let's figure out why Hoffman thinks the old simulation tools are, on their way out, and why he's calling SimTurbo a game changer.
Okay, yeah, let's unpack that right away. Because the whole thing really hinges on integration, doesn't it? Traditionally, you needed totally separate tools for modeling engine performance, the thermodynamics part, and then designing the FADC, the full authority digital engine control. SimTurbo puts both into a single unified platform. And that synchronization right from the get-go, that's what really changes the workflow.
A single platform sounds fantastic, yeah. But those specialized tools, they existed for a reason, right? There must have been technical challenges in fusing GTE performance and FADT design. And what about the user side? You mentioned legacy tools forced engineers to sort of build every component from scratch. What do you maybe lose when you move away from that?
Well, what you mostly lose is the sheer amount of labor, the time, and what you gain is speed. Much faster iteration. SimTurbo tackles that build from scratch issue with its component-based modeling framework, or CBMF. You don't really lose customization, you just gain, rapid synthesis. Users can visually connect pre-built components, inlets, compressors, turbines, PID controllers, you name it, on a GUI. It just speeds up concept design like crazy.
Okay, speed. But the source material mentions it runs complex GTE simulations in real time on just a standard Windows PC. How do you model, say, a multi-spool turbojet and get that kind of calculation speed? That sounds like that has to be a trade-off on the fidelity side.
Oh, it absolutely is a trade-off, a very deliberate one. It prioritizes speed over geometric detail. The software uses high-speed, zero-dimensional 0D, or sometimes one-dimensional 1D lumped parameter models. Component maps are key here. And that speed, it's absolutely vital for dynamic and transient analysis. Think throttle slams, quick power shifts, and probably most importantly, validating the FADD's response to those events. It makes it perfect for rapid software-in-the-loop testing. SIL testing.
Right, SIL. Yeah. So connecting this to the bigger picture then, SimTurbo is really optimized for system behavior, for controls verification. It's not the tool you'd use for deep diving into the internal geometry with high fidelity 3D CFD.
Precisely, yeah, exactly. It's built for the systems architect who needs to know how the whole engine reacts to commands, not for the specialist trying to optimize the, exact shape of a single compressor blade. Different jobs.
Okay, the speed is impressive. But let's shift gears a bit. How does a tool this fast change the market strategy? Because SimTurbo isn't just targeting the established aerospace and power engineers. They're explicitly going after academic institutions, students even.
Yeah, and that's extremely shrewd. It's quite clever, actually. The real leverage here isn't just selling software licenses today. It's about shaping the curriculum for the next generation of GTE engineers. By getting SimTurbo established as the standard educational tool for thermodynamics and controls, Controls Research is building a future talent pipeline already fluent in their platform. That puts pressure, subtle pressure, on the big industrial employers to adopt it just to get their new hires productive faster.
That's a powerful disruption play. And capability-wise, they cover single and dual spool turbojets, complex stuff like afterburners, recuperation, regeneration. That breadth really suggests they want to own this whole control simulation space, doesn't it?
Absolutely. And their roadmap, it signals plans to expand into gas turbine power generation too. So yeah, a clear move into the stationary industrial engine market. That's a huge market.
So bringing it all together, the core value proposition seems to be democratization, right?
Yeah.
SimTurbo makes complex integrated GTE simulation, especially that high-speed transient analysis for FADEC work, accessible and fast on standard hardware. Kind of pulls the rug out from under those expensive fragmented legacy systems.
That's it, exactly. But this does raise a really important question, something for you, the designer listening, to consider. SimTurbo's power, its high-fidelity modeling, it relies on engineers importing proprietary component maps. And those maps, that's often highly protected IP, right? Your company's secret sauce. So as these powerful commercial platforms become essential tools, how do engineering teams need to evolve? How do you securely manage and protect your most valuable internal engine data within these third-party platforms? That challenge. That's the next frontier, I think.